Steve Tomasi, CEO of Boston Centerless, and I'm talking to you about Manufacturing Day today. I want to bring to you what Boston Centerless, who we are, what we do, and kind of an intro into the world of manufacturing here in the United States. Boston Centerless is a precision metals producer. We supply high precision metals into the medical device and aerospace industries, amongst many others, for components such as implants into the body, tools for orthopedic surgery, valves for high pressure situations in the aerospace or aircraft or space shuttle components and things of that nature. So very high precision. A lot of attention to detail is required and such. What's really unique about Boston Centerless is how we do things here. Not so much what we do, but how we do it. We put a ton of emphasis on the people in the business. We want to provide a nice, clean, well-lit environment for our employees and listen to everybody. Everybody is involved with the work and how it gets done, because we want people to be invested in their jobs. There's a ton of opportunity right now at our company. We are growing very rapidly, and we are looking for the best and brightest to come in and help us get there, and people that want to work as part of a team. So enough about Boston Centerless. I want to talk a little bit about manufacturing. I think it's important for people to realize what today's manufacturing is all about. We, as an industry, are pushing the frontier from a technology standpoint. Of course, there's all sorts of metal cutting and grinding and forming type processes that are being done, and they're controlled by computers in many instances. So there's a lot of emphasis on computer technology, information technology, how information flows through the facility from the time a customer calls to inquire about a product or purchasing a part or some material, or all the way to the point of actually shipping that product out the door. And there are opportunities in manufacturing that aren't just related to working on a machine. Of course, we need good people that like to work with their hands and are interested in making things. But we also need people that can talk to the customers, estimate the jobs, procure the material, and buy whatever products and services we need to get the job done. Production control, monitoring the production so that we can give feedback to customers. We need packaging people, shipping people, people in the warehouse, marketing, finance. There's all different opportunities within a manufacturing company. And I think it's just a great place to be right now, because it's very interesting work, and we're serving so many different functions. I mean, one thing to recognize, I'll leave you on this note, there's not a thing that you touch in everyday life that is not somehow impacted by a manufacturer. It's the clothes you wear, you need a machine to do that. That has to be made by a metalworking company. Great opportunities here at Boston Centerless for growth. Join our team or come visit our plant if you're interested in seeing how we do things here. We'd love to have you. Thank you.
All right, hi, I'm Dave Mershrow, General Manager of Boston Centerless. We're here for the virtual tour. We'd like to welcome you to the shop. We're going to follow with a brief tour of the shop so you can see each step of the process. Demonstrate our capabilities. We do round bars that are specifically manufactured for the Swiss screw machining industry. We do up to 3-inch diameter and down to 3 thousandths diameter. We hold 50 millionths tolerance on standard product, 5 millionths on gauging and calibration pins. As part of our capabilities, we also do straightening. We do services for customers who already have material, but we also supply the material right from the mill all the way through to supply the customer what they need. We have one division that does small finished parts where customers can supply us parts, and we'll put the final finish on it. Again, we have about 1,500 customers, all in different industries, and we'd be happy to welcome you to the tour, and we'll step into the shop from here. All right, so this is the front end of the process. Typically, a customer will send in a request for quote. It'll come into the queue, get entered into the system, and our folks in the customer service area will generate the quote, dictate the process, alloy, verify that we have it in stock or if we have to order it. Once the quote's done, it goes back out to the customer. They so choose to place the order. The sales order will come back in. We verify the PO from the customer against the quote, and then we issue the sales order. Once the sales order is into the system, then it will be processed up to OPC up in the corner and materials up in the middle. OPC and materials group, if we have to order material, they place the order. Typically mill runs and that sort of thing, or specialty alloys, we would have to order the material at that point. We do carry a heavy inventory of standard products. If it's in inventory already, then OPC can pull it from inventory and relieve it. Once OPC has it, they generate the traveler, and then they'll look at heats of material that meet the spec, select the one that meets it. So before the job order goes out to the floor, OPC and materials have already dictated which specific heat of material we'll use on the order. So once it goes to the floor, there's no questions about which material, which alloy, which diameter to use. From there, the job orders go out to the manager, the production manager, and he makes the selections as far as which machine it's going to go on, which department, whether it's automatic load or manual, and then he'll issue the job orders to the warehouse for issuing material to the floor based on the priority in which he's going to process them. At that point, we have a red, yellow, green system where if he's already running machines on that specific part, then he'll ask for that one first. And then usually we look out 4 to 8 hours in advance to the warehouse to give them time to push it out to the floor to maintain flow through the manufacturing. So we're at the front end of the process. This is incoming inspection and receiving. When material comes in, first thing we do is receive it physically, put it in QIB, which is a location in the ERP which says it's not released for inventory yet, but it's physically in the building. When we receive material, whether it's customer supplied or coming from the mill or distribution, we do the same incoming inspection. We're going to check it for straightness, roundness, and alloy. We have an XRF that we verify the alloy, and then we just make sure it meets the mill specs when it comes inbound on straightness and diameter. The inspection's done between the receiving bench and the wall barometer, and then once the material is received, it gets signed off and moved into inventory. If it's stock material for stock the right stuff, it will go up into the inventory rack. If it's customer supplied, we'll process the sales order and likely release it directly to the sales order to put it right on the floor. The only other thing that typically comes through here is if it goes out for outside services, heat treat, cutting, what we call OV processing. That same process would happen, it would come in. The only additional inspection we would do is verify, as an example, in the case of heat treat, we would verify the hardness when it comes in. And again, that would be released similar to any other material into the shop. So now we're at releasing. Material is going to come out of inventory, or it's going to be customer supplied material that comes in. There's several different jacket colors. So you see this one's black. The black traveler means it's Boston Centerless supplied material, and then we grind it and ship it. If it's a blue traveler, it's customer supplied material. We call that grind all. And a red traveler, which is the other most common one here, is anything that's behind schedule or an expedite. Scheduling-wise, our biggest issue typically is late inbound material. We would automatically put that in a red traveler to try to make a time up to make the delivery for the customer. As we're issuing, the job order has all the heat information. All those decisions are determined at OPC before it comes out here. The warehouse folks will scan the job order for which heat to use. And then if you look at any of the inventory, everything's tagged with the heat, lot, and diameter on it. If they match that barcode up to the one on the job order, and then they'll relieve the inventory and issue it to the job. You can see different open stock. You can see the smaller closed stock or new stock, and then on the this side up here, your right, is the heavy, higher volume. So these will all be mill runs up here. Typically, the stuff on this side is distribution and obviously open stock. Again, we control all of that information. Heat and lot information is traceable all the way back to the melt source, and we retain all those records for up to 15 years per medical requirements. All right, so now the job order has been released. The first step is to straighten the bars. Even though they come into mill spec, based on the tolerances we grind to out on the shop floor, we have to straighten, about 75% of the bars have to be straightened anyway to get them very, very straight in order to hold diameter and roundness tolerances in the grinders. We process up to 3-inch diameter, but we have capability to straighten bars up to 1.25 inches. Depending on alloy, 1.125 inches is the max based on the hardness of the bars. We have 3 different straighteners. They're all roll straighteners, 2 opposed rollers that actually torque the bar as it's spinning to straighten the bars out. The 3 different machines, the large Miko, which does the large diameters, again up to 1.25 inches. The Shoe Mag does the mid-range, typically 125 up to 3/8, some exceptions again based on alloy. And then the Mini-Me or Mini-Miko does down to 30 thousandths diameter, so very small diameters here. Anything smaller than that has to be straightened by hand, and anything larger we send out. We have several outside services where the very large diameters would go outside to be straightened. At this point, there's several different types of bends. There's a nice steady bow bend in the bar. There's a spiral type bend that's common. And then the worst is a hockey stick or a bar that's relatively straight with a good bend on the end. So the first thing the operator will do, they'll put it on the wobbleometer to see what kind of bend it is. The Miko caliper device can measure the amount, and then based on the type, amount of bend, and alloy, they'll determine which machine to put it on, and they have to set pressures and angles on the rollers. Depending on how bent it is, they'll increase the angles and put more pressure on it to straighten the bars. Again, we're looking at industry standard is 6 to 8 thousandths per foot. In a lot of cases, we have to hold closer to 1 to 2 thousandths per foot based on the tolerances we're trying to hold out on the shop floor. All right, now we're in part of the grinding area. This is the backside of what we call the automatic area. We have 10 machines capable of going automatic load or manual, depending on the size of the job. If it's 10,000 feet or more, we typically will set up for automatic. If it's fewer, there's some mid-sized jobs, we will also go that way if we have capacity. Otherwise, we'll go over to the manual lines. In automatic, they're a little bit different than the standard process where one operator can run 2 machines. You can see the auto loaders. They automatically push the bars. Because the operator is not feeding bars, he can run 2 machines, but he cannot complete the 100% inspection because of the volume. So what we do here is we have a yellow drop box system where the operator will process 20 bars of each lot, drop them into an inspection box, and then a roving inspector will come around and do the 100% inspection. In the case of the manual lines, the operator does 100% inspection, so no bar leaves the manufacturing area that hasn't been verified for roundness, surface finish, and diameter. As part of the process, we also we monitor swarf. We also monitor each machine is set up on a specific alloy. What we do is we segregate the swarf, nickel bearing, lead metals, aluminum, etc. By separating it, we're able to reclaim the swarf. The swarf is drummed and sent out to a recycled company that recycles it, sends it back to the mill, and it's a true closed loop system when we do that. Prior to that, we used to barrel it and dispose of it. There's no hazards in it. The coolants and stuff are aqueous soluble. So it's not hazardous, but it was costing us to dispose of it. Versus now we get somewhat compensated for the salvage, depending on which element, nickel, copper, aluminum, and content of it. The salvage company will tell us how much was in it and compensate us for the salvage. All right, previously we showed the automatic lines where the higher volume jobs go. This is the manual side of the shop. You can see down, we've got 10 machines down this way. Over here we do the smaller jobs, 1 foot up to about 500 to 5,000 feet. They tend to be smaller diameters, quarter inch plus or minus, but this is where we're more specialized in quick changeovers. We're going to do a lot of jobs here versus when we worked in the auto line, you're going to set up for one job and maybe run for days, 2 shifts for days on the higher volumes. Over here, you're looking at per shift, you're looking at 4 or 5, maybe up to 10 jobs depending on the type on a single shift. So the specialty over here is quick change. So along with the quick change, we have manual loaders, so it's easier to set up. It doesn't take the time to set up for automatics. And here the operators are running a single machine. Because they're running one machine, they can check every bar. They check 3 positions on the bar for diameter, they check the surface finish on the finish pass, and they check the roundness on the last couple of passes as that comes into spec. We typically hold about 50% of the customer's requirement. We do that to maintain a tighter tolerance so that when we ship product out, we don't risk being on the fringe or being out of spec. As a result, we've got about a 99.97% customer acceptance rate. Again, because we hold tighter tolerances, statistically we're holding much smaller tolerances than what the customer required. In addition, over here we have quick change on the swarf tanks. They're smaller rolling tanks. Because we're changing jobs a lot, we're able to swap the swarf out, maintain the separation of the swarf for the recycling purposes, as we discussed earlier. All right, now the third type of product, typically grind off, but we do have some of our own products. This is called the small piece area. In this area, the machines are set up with smaller rollers, typically 6 or 8 inch rollers, smaller lengths. This over here, you're going to do 1 foot and smaller. We do down to an 1/8 inch long for some customer products, and typically a grind oil in this area is a customer finished part that just has to have the surface finish cleaned off. The other main product goes in here is our gauging products. We're a XXX certified calibration gauge manufacturer. XXX requires a 5 millionths tolerance on the final diameter and a 2 RA. For reference, a piece of glass is about 6 RA, and we're holding 2 RA, a third the surface finish on pin gauges. In this area, again, we're set up more for very small lengths. We also have better filtration. When we're holding those kinds of surface finishes, even the powder from the grinding swarf is an abrasive. So that micron filtration on these machines to filter out all the swarf from the coolant as it gets recycled back into the machine. And as you can see, the machines are smaller. Typically, there's a pusher here, a person that feeds the machine, and an operator that maintains the machine settings and monitors the finish on the part. So this is higher labor content, but typically very small parts. The other product we produce here is called in-feed, which is where we can do a stepped-down diameter change. We do that on this machine here. In this case, you grind a 12-inch length to a 125 diameter as an example. Then you can go in and change the diameter mid-part to go to a smaller diameter. In this case, it's not a through feed where the parts continually feed through the machine, but it's a set diameter where they actually drop it into a stop. The rollers come in, grind a smaller diameter, and when it's done, you've got a stepped diameter in the part. All right, this is the pin gauge area or gauging area. This is where we hold very, very tight tolerances. The blanks or the starting parts are ground down to a couple of thousandths or a thousandths tolerance out on the machines on the piece area. Then they're brought in here, and this is where the final finish is put in. There's two types of what we call lapping, which is where we do the very fine tolerances. The first is roll lapping, where we do one piece at a time. What Lou's doing here is he's actually dressing the part. By applying pressure at one point or another, you can bring high spots down. And then Kim over here operates the planetary laps, where we can do higher volumes, multiple parts. We set jigs in the machines, and they rotate. So that's two rotating discs that grind the multiple parts as it goes around. Again, we're holding down a 5 millionths tolerance in here. Gauging in here is much different than the standard micrometers out there. We're using laser micrometers. We're using optical micrometers, which can measure down to a millionth. And again, this room is temperature and humidity controlled, 5 degrees plus or minus, and 5% relative humidity. A 5-degree difference in here can actually vary the diameter of the part. So all the parts that leave here, when the customer gets them, they have to set them to the same temperature before they calibrate their equipment. Again, you're talking about millionths tolerance here, where a couple of degrees in temperature will vary the diameter. All right, now we've done manufacturing. Now we're going to go into the quality area. First thing is a lot of customers require ultrasonic testing, eddy current testing, or some customers require 100% XRF to all the bars to verify the alloy. These are typically medical applications, although aerospace also requires UT. So first step in the process, this is a fully automated line. First step in the process, we load a full box of bars here. As the bars roll down, it's going to index them and run them into the conveyor. Prior to indexing, we have an XRS setup that's automated. It's integrated with the machine. It looks for the alloy. If it sees the alloy is correct, it allows it to be loaded. If it sees the alloy is incorrect, it stops the line and flags the operator. This way you know the only bars that go into the machine are the correct alloy per the settings on the machine. Next step is it's coming through the operation. We have an eddy current coil. It's an electromagnetic coil that verifies if there's any cracks, pits, or other surface defects in the bar. This is, again, important because about 80% of the bars that we ship out of here, the outside diameter is completed. It's finished. The customer will put features in the bar, but the outside surface of the bar is already complete. So any pits and scratches, obviously they want to know this allows us to tech that. The next step is the ultrasonic head. This is a submersible, a water submersed ultrasonic test. This is testing for defects inside the bar. Similar to sonar on a ship, it sends out a signal which goes inside the bar, reflects off any defects. Down to 1,000 diameter defects can be detected. Some alloys we have problems because the molecular boundaries inside the alloy itself can cause a reflection, so we have to adjust it depending on the alloy, the diameter. We can go up to 1 inch diameter down to about 200 thousandths diameter through this line. It's a high-speed automated line. We have calibration standards depending on diameter and alloy. This whole system is run automatically by the main computers. It automatically rejects bad bars and accepts good bars. If you look over the back, the right side is the reject table, so it automatically, if it sees a defect, it sorts it to the back. If it's a good bar, it sorts to the left. If it's a bad bar, sometimes depending on the location of the defect, you can cut off the last inch or where the defect is and still use the balance of the bar. So we do measure, it tells us where the defect is, we check it, and if we can salvage any of the bar, we will. All right, so now in theory the job's done. If it requires testing, it's been tested. Now we're going to prepare it for shipment. So in a lot of cases, customers require a C of C or they require additional inspection, sampling plans, retention samples, stuff like that. We also do PPAP and FMEA inspections here in inspection reports for medical and aerospace folks. So the first step is the QA engineer will review the certs on the material against the customer specs, verify that everything indeed matches. Now, we've done that at the front end of the process, but we do it once again at the tail end to make absolutely sure that everything meets the spec. They'll also look at the inspection reports from manufacturing, and they'll look at the UT certs and combine everything to get a final C of C for the job. Once that's done, the C of C is prepped at this station. All the documentation is electronically transferred over the shipping, so when they ship the packing slip, it automatically prints up all the documents. Again, in here we have another Z mic. They're also verifying any calibration standards that come in here. They're verifying pin gauges, and they're doing any final inspections, additional inspections that the customer requires. In addition to the Z mic, we have a automated roundness gauge. The roundness gauge can measure down to 2 millionths in roundness. Gives us a plot, lobe plot of the diameter of the bar. The idea being you want it as round as possible with no lobes. We also have microscopy with photographic capability. If a customer has an issue, they can send us a sample. We can do an evaluation on it, including taking magnified photographs. We have a profilometer here. This one can measure down to 2 RA. It's obviously a fixed station. The shop operators have manual profilometers that can measure down to 8 RA, which is typically half what we need to hold on the shop floor. In addition, we have a super mic. This measures millionths for pin gauges. Most product goes here. We do have some customer products that require millionths tolerance. That would also come in here. Again, temperature and humidity control to be able to maintain those tolerances. At this station, we do our own calibration of all our hand mics and shop tools. Now, we do have outside service. We're NIST certified for our calibration capabilities, but things like this flat stone, the roundness gauge, the super mic, those get calibrated every 6 months by an outside service, and then we use those as standards to do our calibration for all our manual operator tools. All right, so now we're at packaging. QA has already looked at the job. We've already done our testing. Bars are ready to go. Most jobs, when they come off the production line, are packed right into the shipping crate immediately. The only time they're not is small jobs. A couple of bars will come over and be put in the tubes. There's a final check on it, final QA audit, samples just to verify the job. But at this point, we're going to pack it in whatever way the customer wants. So our standard packaging is 4x6 B box. We can put roughly 200 to 400 pounds in a box. That's our standard. We have other custom options, which include PVC tubes, cardboard tubes. We also do individually wrapped in either a plastic sleeve or in a plastic mesh. If it's got a real fine finish, we can wrap it that way, make sure there's no abrasion. Once packed, we chalk the end of the bars to prevent them from sliding. We also put wadding and blocks to hold them down. The whole idea is to try to ensure that the bars get to the customer in one piece. We do cut flanks and such. We have custom crates built for those, so they fit. Again, everything needs to fit tight in a box so it doesn't shift around during when the carrier picks it up and ships it. Final step is to bring it in for the paperwork. As well as CNCs, bill of lading, carriers selected. We have several of our own selected carriers that tend to perform better on this size product, but we also work with any carrier that the customer may contract. So we use theirs, in which case we're responsible to leave our dock, or we prefer to be responsible to get it to you, in which case we typically select a preferred carrier on our end. From there, the box ships out the door, and then we just confirm that it's gone to the customer, and then we're ready to invoice. So this is the Boston Centerless quality policy. It's posted throughout the shop. Part of their onboarding, employees are required to understand what it says. In an audit situation, they don't have to quote it back, but they need to understand that this is what we're attempting to supply the customer. Perfect quality, on-time delivery, exceptional service, troubleshooting when required, technical help when they want it, and this quality policy has stood up to the test of time. It was developed years and years ago, but it has stood up and is consistent today. And any operator that you walk in and ask them about quality policy, they'll know the main topics in there: training, teamwork, initiative, excellence, quality. They'll know the main thing. All right, we also have our type values, again, posted all over the shop. Each operator is initially given a little pocket card that explains what the type values are: trust, initiative, team first, and excellence. This, along with our quality policy, drives everything we do here. We hire and fire to these values. If an operator does not show willingness to support those values, he'll be counseled and could potentially be moved out of the area where he's working. However, we have a multi-interview process where we bring even machine operators all the way up to executives come through a multiple interview process where we get 2 or 3 different people to interview them to verify that they're going to be able to live to these values. So again, the type values are very important here. So right down Main Street, center of the shop, we have banners not only showing what the value is, but giving a brief wordless description of what the definition of it is. Again, we have multiple cultures here. We want to make sure that when we say initiative, whether you speak English or not, you understand what initiative means. Taking the time, pushing ahead, taking the extra step to satisfy the customer. In addition, Boston Centerless has several industry certifications. Our testing capabilities are NADCAP certified, which is a grueling certification for the aerospace industry. We have AS9100, which is an ISO certification for aerospace. We have ISO 1345, which is specific to medical products, implants, and instruments. And we have ISO 9001 for manufacturing, which is the basic manufacturing certification. All these certifications are maintained regularly. We get certified and audited annually, and it also allows us to demonstrate to our customers that we are capable of doing any product in the industry. Okay, as always, there's one very important component of our process, and that's our employees. It takes a long time to certify an employee to grind, 9 months to a year to get fully capable to produce the product. We have 30 machines, we have 2 shifts. We need consistent product coming off of every machine, no matter who the operator is, no matter what the hour is. So we do our very best to cross-train, and then typically as operators get certification or they contribute to satisfying the customer, we want to make sure we recognize that activity because it's incredibly important to maintain the quality and the standards that we've set here at Boston Centerless. So a few things that we do from a recognition standpoint: we have our picture board, no titles, nothing. This is strictly by seniority. You can see the top row is employees that have been in here over 10 years that retired from Boston Centerless. We have 126 employees, and again, we do a very good job for the customer. And the reason they're doing a good job for the customer is we make sure they're recognized and rewarded for doing it. Behind me is the golden bar. This is an award given to one employee, potentially a team, per month. It's nominated by 4 employees. They're nominating one of their own that has done something to go above and beyond their normal daily job. They jumped in and helped another operator. They spotted a problem and addressed it without being asked. They jumped in a truck to deliver a hot job without being told, anything like that. exceptional performance out in the office, customer service. When a customer service representative gets recognized by a customer for being exceptional, we'll recognize them as well. So again, they're nominated by a fellow employee. Executives cannot win it. We have a continuous improvement committee that is the judge. We typically get five to six nominations a month. One will win it. They all get recognized. So the winner, the only thing that separates the winner from the other nominees, they all get BC Bucks, which is a program we have where they can buy a shirt or a hat or trade it in for a gift card. But they all get rewarded. The one thing the winner gets is they get a certificate with a picture on the wall for the month, and the big prize is they get the front parking spot reserved for the Golden Bar winner. We found that that's been an incredible incentive to operators to try to do the right thing. When it comes to training and processes, a couple of things of note. Our rate process is merit-based and skills-based. So as an operator gains more and more skills, he can work himself up the payroll scale on his own by gaining more skills, becoming more flexible in the process, and be able to contribute more. So that's in the operator's own control. When an operator makes an error, it is not, we never discipline for an error. If they have, because they report the scrap themselves, there's no reporting on them. It's all self-reported. And when an operator has a problem, maybe he has a problem with setups, we'll just put him back in training and retrain him. Maybe he hasn't run an alloy for a long time, so we'll retrain him on that. So we watch timing and time since the last certification. Certifications are all monitored. It's an electronic database. But again, we post it out here so the operator knows where he stands. But largely, he can see where there's opportunity to increase his value to the company and potentially increase his compensation. Finally, we have an extremely diverse crew here. If you look up, you can see the flags. These are the country of birth of every employee in here. Obviously, the United States, you've got countries like Barbados, Cambodia, Vietnam, South American countries. There's about 15 different countries represented here. Very diverse crew. We have English as second language if required. We're happy to bring in employees. If you want to work and you want to do high quality work, we'll actually help assist you in learning how to speak and read English. So again, you contribute more and increase your value and contribution to the company.